Alright, in this video we're going to learn how to solve second order linear homogeneous equations with constant coefficients. So let me go over those pieces really quickly. So we have constant coefficients, so A, B, and C. We notice that the t doesn't show up, but it would still be linear if it was A of t, B of t, and C of t. Alright, then it's second order. That's not so hard to see. It is a linear equation, and when I say it's homogeneous, I just mean that this portion here is 0. So the part of the function without a y is 0. Alright, and to solve such an equation, we're going to just assume the solution looks like y equals e to the rt. Now it might seem like a big assumption to make, and it is. However, in this case, notice that when we differentiate this function, it doesn't actually get a lot more complicated. We just get the same function plus some scalars. So that's kind of consistent with the a, b, and c being functions without t's. Alright, so let's figure it out. Y prime would then be r e to the rt, just from our chain rule, and y double prime would be r squared e to the rt. Remember, t is our variable and r is just a constant. Okay, so if we plug those back in here, we're going to get a times r squared e to the rt plus b times r e to the rt plus c e to the rt, and this equals 0. We know how to solve such an equation. We could factor out e to the rt, leaving us with ar squared plus br plus c. Multiplying this out, we get 0. And that right there tells us how to solve it, because e to the rt can't be 0, no matter what t is. It doesn't even matter if t is a complex number. That can never be 0. So this implies that ar squared plus br plus c equals 0. That's a quadratic equation, which we can solve either by factoring or using quadratic formula. We call this the characteristic equation. So we're going to be able to jump straight to that equation from what we've been given up here. So we don't have to do all this middle ground stuff each time. We can jump straight to that equation. Alright, so what would that look like? Well, let's try a problem. So for this problem, let's solve y double prime plus 3y prime plus 2y equals 0. Okay, to solve that, we can jump straight to our characteristic equation. So the characteristic equation is r squared plus 3r plus 2 equals 0. And that factors very nicely for us as an r plus 1 and an r plus 2, which leads us to r equaling -1 or -2. Now that we know the possibilities for r, we know what the possible solutions might look like. So we know that y equals e to the -t and y equals e to the -2t are solutions. Oops. From those two solutions, we can actually get the general solution. So the general solution is y equals, I'm going to do c1 times the first solution, so c1 e to the -t plus c2 e to the -2t. And in upcoming sections we'll talk about how we know that's the only solution, but As you might recall from linear algebra, you can take linear combinations of solutions to homogeneous equations and come up with a new solution, and this will be all the solutions that we can get. So we'll follow this procedure each time.